before our test is 2.5. Transformations. Before we talk about transformations, and before I explain what they mean and why, can we live without transformations? Yes, quite well. But why do we study transformations? Maybe I should start with this. To be able to identify patterns, to be able to say, and I'll show you a nice example. Be able to say, oh, I think I know this kind of fits an absolute value function or a quadratic function or a radical function. But first, of course, we need to know those basic or base functions. So let's list a few. Okay. So basic or base functions. This is how I like to call them. Functions. Number one, linear. Can anyone give us the simplest possible linear function that you can think of? F of x equals, way complicated, x. The simplest possible linear equation is x. And this is so important. It's such an important function. You'll see what happens at the end of chapter 2 with this function. This is the graph. F of x equals x. Can anyone tell us whether this function is odd, even, or none of the above? So let me refresh your memory. Even function is symmetric with respect to the y-axis. So what I have here, I have to have here, identical, identical, identical. But if it's symmetric with respect to the origin, what I have here, I have to have here, identical across the origin. If I do, it's symmetric with respect to the origin, or this way. And that would be odd. Odd, even, or none of the above. What do you think? The function is odd. It's symmetric with respect to the origin. What you have in the first quadrant, you have a copy in the third. So the function is odd. Can anyone give us the simplest possible quadratic function? The simplest possible quadratic function. F of x equals a function that is quadratic. Absolutely. Simplest possible quadratic function is x squared. Well done. Thank you, Michelle. Excellent. So here it is. Good. Odd, even, or none of the above? Of course. We used it to illustrate even functions, of course. Absolutely. 3. Radical. We have 2 for radical that we are going to look at. F of x equals the square root of x, and f of x equals the cube root of x. 2 radical functions. Here's the graph. Any questions? Any questions? Megan, go ahead. Any questions, please? Okay. So here it is. This is the square root of x. Odd, even, or none of the above? One more time. Let's illustrate this one more time. If a function is even, what you have in this first quadrant, you have to have a copy in the second. If the function is odd, what you have in the first, you have to have a copy in the third. Or what you have in the second, you have to have a copy in the fourth. Odd, even, or none of the above? Not symmetric. Excellent. Perfect. Here's the cube root of x now. Kind of like the cube root, the square root, not really. This is the cube root. Odd, even, or none of the above? Excellent. Very good. Odd, symmetric with respect to the origin. Okay, I want one more, although we can come up with others, but four are good enough for now. So absolute value. Can anyone give us the simplest possible absolute value function? That's it. That's the simplest possible absolute value. And here is the graph. You understand it without remembering these functions, we will not be able to use transformations. Okay? They are the basic functions. So here it is. So this is the absolute value of x. Odd, even, or none of the above? Of course, it's an even function, completely symmetric with respect to the y-axis. Excellent. Okay. We're going to look at the following transformations on these functions.
Can I say the linear?
Yes. The linear function? Yes. You're welcome. Perfect. Transformations. Here they are. Shifts. Reflections. Stretching, shrinking. Shifts. Thank you. Shifts. Reflections. Stretching, shrinking.
What is it?
Shifts. Reflections. Stretching, shrinking. Shifts of two types. Horizontal, vertical. So shifts, reflections, stretching, shrinking. Shifts, reflections, stretching, shrinking. Shifts, two types, horizontal, vertical. Reflections, two types. WRT with respect to the x-axis, y-axis. One more time. Shifts, two types. Horizontal, vertical. Reflections, they can be with respect to the x-axis or with respect to the y-axis. Stretching and shrinking, vertical, horizontal. Okay, let's start with shifts. Should I read this again? No excuse, I'm standing and that's why my handwriting is not perfect anyway. But do we understand, or should I read this again? So transformations, shifts, reflections, stretching, shrinking, shifts, horizontal, vertical, reflections with respect to the x-axis or the y-axis, stretching, shrinking, vertical, horizontal. So let's start with shifts. Okay, let's say I want to create the function x squared plus 2 and another function x squared minus 4. And we are asked to, first question, what is the base function that I used to create f of x? Of course, the base function is x squared. Excellent. Like for any transformation, I will always ask you, is there a change in x or a change in y? So here's why. Every time there is a change in x, something will happen horizontally. Anytime there is a change in y, something will happen vertically. So that's our first thought. When we are looking at a function, we're asking ourselves, okay, from here, there, is there a change in x or a change in y? That's the very first thought. So now let's compare. I'm comparing x squared to x squared. Do you think there is a change in x? No. So then I'm comparing x squared to x squared plus 2, which, since we established this piece is the same x, no change, no plus or minus touches x, then it must be a change in y. It must be a transformation that either moves the graph up or down. So when I graph x squared, which is this, how will you graph x squared plus 2? And let me just remark one thing. When we are graphing using transformations, we're not really interested in an accurate graph. I'm not going to plot points. I'm interested in the shape quickly to see what the pattern is, what the trend is. So what do you think this transformation is doing to this? How is this changing this graph? Exactly, that's it. Well done. So here's the graph. Same shape of x squared plus 2. So here's the graph of x squared. So this is a vertical shift. In this case, it was up 2. What would you say about the other one? That's it. And we're done with vertical shifts. But just remember, vertical shift requires a change in which variable? In y variable. Excellent. Next one. Questions? Yes, here it is. You need some?
No.
You're welcome. Good. Now I create another function. I want to create the absolute value of x minus 3. And I want to create the absolute value of x plus 2. What is the first thought, the first question? What is the base function that was used? What function did I use now? I didn't use x squared. I used the absolute value of x. And now I'm asking myself, is this identical here? So it must be a change in, there must be a change in x. So when I change x inside a function into x minus 3 or into x plus 2, which did not happen here. Here I had x squared or x, and x stayed the same. X squared and x squared were the same. So the change happened outside of x. But this time, the function is the absolute value of x. The argument in this function is changed into x minus 3, and respectively, x plus 2. But now the idea is, where do I shift the graph? It's clearly a horizontal shift because I change x. But the question is, where is it going? And I don't want you to memorize this. Okay, so when I graph the absolute value of x, I graph the even function that bisects the first and the second quadrants. This is the base function, the absolute value of x. So now the question is, where does this go? See, this point is at the origin. Where do you think this will go? What x value will keep this value of the function 0? In other words, where is the x-intercept of this? Negative 3 minus 3 will not be 0.
Oh, 3.
Exactly. So therefore, when I change x into x minus 3, where is the graph going? Exactly. Awesome. Well done. It is going to the right. Please make it parallel. So this is the absolute value of x minus 3. So now where do you think will x plus 2 go? And remember, I'm looking for the x-intercept. Where will the x-intercept be for x plus 2? And then you know exactly where the graph is going. And negative 2, therefore, is going to the left 2. So this graph is the absolute value of x plus 2. Awesome. So now I would like a combo with the two. So this is, of course, horizontal shift. When we change x into x minus, it's to the right. When we change x into x plus, it's to the left. So I want a combo like, for example, f of x equals the square root of x plus 3 minus 2. Understanding transformations, it will give you a totally different view into functions. Yes. So one thing that I have to write, and please note, is transformations are presented in the order of operations. One more time. Transformations are presented in the order of operations. Yes?
I'm sorry, one quick question. That absolute value of x plus 2, why is it in the negative again? How did that go negative?
So if I want to move this to the right, if I want to move x plus 2 to the right, then the x-intercept, see, here, only 3 minus 3 will give us this point. Here, only negative 2 plus 2 will give us this point.
Oh, because it has to be equal.
It has to be on the, yes, on the x-axis, right? It's a horizontal shift. So this, for which x value will this function be 0? For 3.
3, right. Okay.
But if you want to move it here, negative 3 minus 3 will not be 0. Negative 3 minus 3 is 6. Right? Negative 3 minus 3 is negative 6. The absolute value is 6, and the point is up here.
Okay. But, so it's 2.
Negative 2 plus 2 would be 0.
Okay.
So if you want to plug in here positive 2, 2 plus 2 will be 4, the absolute value of 4. So at 2 is this point.
And that's only because the origin, because it's at the origin, right?
Because I have to find the x-intercept.
Okay.
Yeah. Or you just remember that when we change x into x minus 3, the graph moves to the right. And when we change x into x plus 2, the graph moves to the left. I just didn't want just to ask you to memorize that. I wanted to show you why. Okay, transformations are presented in the order of operations. So I'm given this function. Let's say I want you to evaluate this function for x equals 6. Where do you start and which operation you perform first? Into the square root. So first you are going to apply the operation 6 plus 3. And then you apply the square root. And at the end you subtract 2. Therefore, the transformations have to be presented in the same order. Can you tell me which function did we use this time as the base function or basic function? The square root, not the radical. We have two radicals, right? We have the square root and we have the cube root. Under the umbrella of radicals, we have two different ones. Good, excellent. So number one, what is the first transformation on the square root of x? What is the first operation I will perform?
To add the square root of x plus 3.
Exactly, so I have x plus 3. What transformation is the square root of x plus 3 on x? The square root of x. Yes, are we changing x or are we changing y? Excellent, well done. And where do I shift it to? To the left. Very good, left 3. Right? When we change x into x plus 3, we shift it to the left 3. And now number 2 is the square root of x plus 3 minus 2. So number 2 is a transformation on number 1. Am I changing the x? No. X is the same. X plus 3, x plus 3, they're the same. So what am I changing now? And where does the graph go? So I'm changing y, and where does it go? Exactly, very good. Down to, awesome. So let's show all transformations. I have to start with the base function. The base function is the square root of x, here it is. Then you told me to shift this graph where? One more time. To the left 3, very good. 1, 2, 3, awesome. Thank you, Danny. And then you told me to do what as the final transformation? You set 2 down, right? Here it is. I don't know exactly where it crosses the x-axis, the y-axis. I'm just going to graph. So this is the square root of x plus 3 minus 2. This is final. This is the final graph. So this was a combination. We decomposed it into 2 transformations. One was a left shift, and the other one was a vertical shift. Down 2. Any questions? Please ask anything.
If it was x minus 3, then it would be to the right.
Exactly.
Okay.
Yes.
Okay.
Indeed. Good. So now let's look at reflections. So let's say we have f of x, the square of negative x, and g of x, negative the square root of x. I created 2 new functions, and I would like you to tell me which function I used. Which of the simplest possible functions I used to create these 2. Excellent. I used the square root, so the base function, the square of x. Now please analyze in the first case and tell me what we changed.
The x.
Exactly. It's not identical, right? This is an x in here, and this is a negative x. Okay, so now let's see what happens. If I have 5, and then I say negative 5, 5, negative 5, or I say negative 10, the opposite, 10. What am I doing with this graph? Reflection with respect to?
The x.
One more time.
No.
X negative 5, negative 5 for x. We'll establish that we're changing x. So it cannot be something like this. So once we establish that we are changing x, it cannot be vertical. Right? Is that clear?
Right.
Very good. So this, here's the graph of the square root of x. And this is a reflection with respect to WRT, the, one more time. Very good. Y-axis. Here it is. Here's the graph. This is the graph of the square root of negative x. Well done. Let's analyze G. What changes in G? Exactly. Because you see the square root of x is the same. This is with positive and this is with negative. But the square root of x is not touched. Still the square root of x. So what am I changing now then? Of course, you already answered. So from positive 5 to negative 5. Or from negative 10 to positive 10. What am I doing now to this graph? Well, I'm reflecting it with respect to? I'm reflecting it with respect to the x-axis. So this is a reflection, WRT, with respect to the x-axis. So let's graph it. Here it is. Okay, a combo now of all of the above. let's say f of x, because negative, bless you, the absolute value of x plus 1 minus 3. All transformations have to be presented in the order of operations. So please identify the function that was used, the absolute value of x, the first transformation on the absolute value of x, and where it's going. So please dictate the first step, the first function.
With the absolute value.
The absolute value of?
X plus 1.
Awesome. Where does it go? Left one. Awesome. Excellent. Number 2. Remember, number 2 is a transformation on number 1. Now you are comparing this to this. What transformation is that? It's a transformation on?
X. Sorry, it's on the transformation on Y.
Very good. What does it do? What does this operation do to this function? Reflect WRT with respect to? Very good. Awesome. Thank you, Michelle. And the last one, negative the absolute value of x plus 1 minus 3. Now I compare this. I compare this to this. Exactly. Awesome. Thank you. Great job. Thank you. Down 3.
And which axis is it? We're just going to just
The x-axis. Because I'm changing y. When I change y, it's a transformation on vertical transformation, right? When I change x, it's a horizontal transformation. That's why I always have to ask myself, what am I changing? If you say x, then expect something to happen this way. If you say y, expect something to happen this way. That's why that is always the first question. So let's graph all these. I will graph the absolute value first. Here it is. Then you told me to shift it where? One more time. Here it is, left one. Oh, if I missed it a little bit. Sorry. Good. Then you told me to do what? Okay, I'm reflecting it. And then you told me to do what? Very good. Final. F of x equals negative absolute value of x plus 1 minus 3. Once you understand this, you know exactly how this function will look like. Can anyone identify the range of this function? We haven't even determined plot. We haven't plotted points per se. So what will be the range of this function? From negative infinity till negative. That's it. So the range, negative infinity, negative 3. Okay, last transformation.
those are where the points hit, right?
So this was at negative 1, and because we shifted it down to negative 3. So from negative infinity till negative 3 for the range. From the lowest y value till the largest y value. Was that the question?
Yes.
Okay. Is that clear?
Yes.
Good. Last transformation. Stretching, shrinking. I'm only going to present the vertical. I'll leave the horizontal one, which is slightly different, for test 2. So vertical, stretching, shrinking. Not both, of course. If it's vertical stretching is one thing, if it's vertical shrinking is something else. Okay, so here it is. Let's look at f of x. equals twice x squared, and g of x 1/3 x squared. Okay. Base function, please. X squared, very good. Again, we have to identify. Once I put vertical, and I should have not put it just yet because I want you to identify it. But what am I changing? I'm not changing the x because x squared does not change. X squared is the same. I'm not changing x inside the function. So this is an outside. That's why it's vertical. So we are changing y. So here's x squared. If I multiply all y values by 2, what will happen? This or this? Yes, vertical stretch. Because now all y values, this is 1. But now it becomes 2. Right? So the base function is x squared. But twice x squared will look like this. Because now all y values get doubled. So this is a vertical stretching. Vertical stretching. What transformation is 1/3 x squared? Is it on x or is it on y? Of course. But this time, I want all y values to be divided by 3. Not multiplied by 2, but divided by 3. Multiplied by 1/3 means divided by 3. So the first one was a vertical stretching of the graph. What do you think this one will be? A vertical? Yes, we are shrinking the graph vertically. So this will look like this. 1/3 x squared. And this is a vertical shrinking. Of course, by a factor of 1/3. I like to illustrate with a combo also, and then look at a word problem. Because I'm sure you're asking yourself, wonderful theory, what do we do with it? So let me just show you a quick combo and look at a graph. Let's say -1/2 the square root of x plus 1 minus 2. Now, by simply looking at this, you should have an idea in your head of the graph, right? So here is the square root of x. Then where do I move it to first? To your left, 1, and then I reflected, because these are 2 steps. I have to multiply by -1 first and then multiply by 1/2. I reflect, right? I open up the graph a little bit more and I shift it down too. So, which base function are we using here?
Square root of x plus 1.
The base function is the square root of x. Good. First transformation, indeed, the square root of x plus 1. Where do I move the graph?
To the left.
Left 1. Number 2, negative the square root of x plus 1. You can say, why don't you multiply by -1/2? Because we don't do this. We don't perform this operation first by -1 and then by 1/2. Because they're 2 different transformations. That's why. The -1 is one thing, and the 1/2 in front is something else. So what does this do to this graph?
Move it down.
Careful.
No,
Reflection
reverse to the
with respect to, I'm not changing x, always remember, I'm changing y, which means reflection with respect to
Right.
the, no,
to the axis.
yes, it's vertical. So it's a reflection with respect to the x-axis. And number 3, Negative 1/2 the square of x plus 1. What does this do to the graph? And what am I changing? Always remember to think. Am I changing x or am I changing y?
Y.
Very good. So this is a vertical shrinking by a factor of 1/2. By 1/2. And the last one is negative 1/2 the square of x plus 1 minus 2. What does number 4 do to number 3?
Bring it down to.
Very good. Vertical shift down 2. Awesome. Okay, we can graph this next time, but because I only have a few more minutes, like 6 minutes, and I like to look at why we do this. Why is this so important? And I want to show you an application. Okay, here it is. What do you think about this? I really didn't want you to see this function. Let's say we don't have it. Well, just don't look at it. Okay, so here's what I see. I don't see this. I don't see this. I don't see this, which was the cube root. Well, what do I see? What function do I see? What does it resemble? It's not quadratic. It's not linear. It's not the absolute value. It's a square root, obviously, right? Good. So it is definitely shifted up. And it also has some factor of stretching in there, like 2.9. So what is this? The problem says the function blah, blah, blah models the median height, f of x, median height in inches of boys who are x month of age. Okay. Part A, describe how the graph can be obtained using transformations. What is the first transformation? That is the base function. The first transformation is multiplied by 2.9. So when it's a vertical, stretching by 2.9. And then, yes, vertical shift up 20.1. Very clear. Okay. Part B. According to the model, what is the median height of boys who are 48 months? Use a calculator to round the actual median height such and such. I just did this problem with my previous class. So here's what I recommend. Let me start from scratch with you. So we put in the function in y equals 2.9 the square root of x outside plus 20.1. The square root of x plus 20.1. Okay. The problem is asking us to plug in this function several values. And here they are throughout the problem. 48, 0, 10, 50, and 60. So go to second and table set. Make sure that the independent variable is in the ask mode. So go to table set, second and table set. And make sure that the independent, just the independent, is in the ask mode. And then let's plug in those numbers. So now go to second and table. Of course, the calculator already has them. The software already has them. So yes, just the independent, just the x, because you want to put x in there. Press enter. Just the x value. Are we okay? And please plug in. Yeah, that's good enough. So, so plug in 48. Plug in 0. 10. Yes. You just have to scroll down. Scroll down and highlight that, and then second in table. And you can just plug them in. 48, 0, 10, 50, and 60.
How do you get the table? Yeah.
Second in table.
Second, okay.
So go outside, plus 10, what was it, plus 20.1. And then we go to second in table set and scroll down and highlight to the right, just the independent, and press enter. And now second in table. No, table. Okay, second in table. One more time, second in table. Yes, and plug in those numbers because we need them in a minute. 48, 0, 10, 50, and 60. I know I only have 1 minute, so I could stop and we can finish this on Monday. I don't want to hold you. It's up to you. And we'll finish that. Any questions for me?